We are going to go over just a few of the examples from the 5.1 and 5.2 review worksheet. I'm just picking out a couple so you get the general concept and idea. So this first one that we're going to do is number 8, where you're buying an Inspire calculator for $125. The value of the calculator increases by 12% each year. Imagine that. So we're going to write a model for the value V of the calculator after T years. And then it's asking me, when will the value be twice as much? That would be probably a question mark after that. All right, so we have something that we buy. So that's our original amount. That's our starting amount. And then we're given, it increases. So we know we're going to do growth by 12% each year. And that's our rate. But we have to remember that when we do the rate each time, we need to put it into a decimal form. So now if we look and we think about the growth, I'm going to have 1 plus a rate. All right, so that's always my growth factor. And we want it with V. We always want the starting amount in front of the growth factor, and then our variable for the exponent, t. So here is our model, and this model is what we would use to put into the calculator if we need to find something. And if I wanted to, it doesn't say it on here, but if I wanted to find it after the value after 4 years, I could simply put in to t 4 if I wanted to find 4 years, and I would know the value. And if I want to go ahead and do that on my calculator, I can just put 125. I'll use the parentheses, 1, and then I can add this together. Let me do that here. 125. Make my model a little more simplified. And then I am going to raise it to the 4th power. And we get around $196.69. So after 4 years, my calculator is almost $200 if this model works over an extended period of time. So the next thing it asks is, when will the value be twice as much? So if I want the value to be twice as much, I guess I should have said from when we purchased it. I'm looking for the value to be $250. When do I get to $250? So this is when I'm unsure of this ending amount. So I'm going to go into my calculator. I'm going to open a new document so that I can make sure I have a fresh graph. And I'm going to put in our original model, 125, 1.12, raised to the, now please don't put t in, put x. Our variable when we graph should always be x. I'll hit enter. As we were saying, we can't see it, so we go into menu and we zoom. And I'm gonna, oh, there we go, we're over here. So I'm gonna show us where it is. Once we see the graph, we can go into the table and we can look for, I don't know what's gonna be easier for me to do. There we go. We're gonna look for around $250. Oh, it's somewhere in here between 6 and 7, but I want it to be more accurate. So we can go to menu, table, edit table settings, and we can change the table step. So maybe I want 0.1. We'll try that. So now I see 4, 4.1, 4.2. I'm going to get a much better estimate of where my 250 ends up. I have to scroll a little longer. There we go. So 250 is somewhere right in here between 6.1 and 6.2 years, probably close to 6.1. So we'll say around 6.1 years, or a little after 6 years. The calculator is twice its, and then I'll stick this in there because it's what I really should have written, original value. All right, so now let's scroll down a little bit and look at this next piece. So this says the number of students with cell phones in an elementary school can be modeled by C of t equals 150 times 1.06 to the t, where t is the number of years since 2008. So 2008 is my starting point. At my time when it's 0 is at 2008. So how many cell phones were there in 2008? Well, when time is 0, that's going to make that kind of change to a 1, but we also know that this is our starting value, so I don't have to do any calculations. There was 150 students with cell phones in 2008. So what's the growth factor? Well, the growth factor, remember, is our base. It's what's being multiplied by itself t number of times. So this is our growth factor. So that's 1.06. But now I want to know the percent increase. I want to know what was the rate of increase. Well, if when I have growth and my growth factor is 1.06, well, that had to come from 1 plus something, 1 plus a rate. And we're going to hopefully get kind of common and used to it, saying that, well, 1 plus what gives me 1.06. It's much easier than the decay. But if you want to see the algebra behind that, we'll subtract 1. We're left with 0.06 equals the rate, and then we always want it as a percentage. So the percent of student, or the number of students that have cell phones goes up by 6% each year. So remember, factor is what's the base of this exponential function, and the rate is what it's increasing by each year. They're a little different. All right, this last one is about someone wanting to go on vacation to Mathland Island. They want to go in 5 years, so you know this is the cost of the trip. But right now, my starting amount, I'm going to deposit $3,500. All right, so this here is my principal. It's my starting amount. And I see that I have a rate of 3.44, so that's 0.0344 when I use it. And I have two situations happening. I'm going to compound this semi-annually, so I'm going to compound it a certain amount of times per year, and compound continuously, meaning that I'm going to continually add money from my interest onto my account. Oh, and we also have this 5 years, and that's our T. So let's set up this compounding periods where we're given the number of times you'd like to do that in the year. So let me write the formula. There we go, times n to the t, and we'll just fill everything in. So our principal is $3,500. 1 plus my rate. Make sure to use this decimal. You're going to get an interesting number. My number of times they're compounding are semi-annually. So that means twice a year. And then we have 2 times and how long we want it, 5. So we're just going to go ahead and put that all into the calculator. And 3,500 times 1, don't forget the 1, plus, I'm going to use the fraction key, 0.0344 over 2. Go off to the side, make sure that I create an exponent. 2 times 5. There we go. So we have approximately $4,150.80. Is that enough? No, it's not enough. Darn it. Well, let's see what happens if we compound continuously. So that's going to give us a different formula. We have to use the continuous compounding formula, which is A equals P times e to the RT, which I call PERT. So we have $3,500 times e. Remember, e is not a variable. E is the constant number that's irrational, 2.71, and it goes on forever. So they assigned it a symbol. My rate didn't change, and my time is still in 5 years. So if we go ahead and put that in the calculator, 3,500 And here's our e. So we're going to say times e, and it opens up a exponent right away. And we'll put that in, and let's see how much money we have now. We have 4,156.87. So do we have enough? Yes. So in this situation, when it's compounding continuously, we do have enough. We have 87 cents to spare. Maybe go buy some gum if it's on sale. So that's what we have going on for the modeling for exponential growth and decay. One other thing I wanted to just touch on is that if we had a decrease here in this particular problem, the value decreased, what would have happened is we would have had 125, v equals 125, 1 minus 0.12 to the t. So if we had a decay or a depreciation, we would have gotten a decimal point here. So we would have had 0.88 to the t, and we would have noticed our value going down for it. And another thing I want to mention is if this particular problem here looked a little different, let's say the number of cell phones, people started getting rid of them, was let's see, 7.5. And this is what our problem looked like. We would still have the same starting amount, but what would happen is our growth factor, we notice, is a decimal point. It's 0.75. So that means we have a decay or a depreciation. So if I want to know the rate, I'm trying to figure out, well, if 0.75 is my factor, it came from 1 minus something. And 1 minus 0.25 is going to give us 0.75. But again, if you want to see the algebra, you're going to get negative 2.5 equals negative r. Remember, we can't have that negative variable, so we make them both positive. So my rate would have been 25%. So that's just if we had to go the opposite way.